One of the ways that molecules are formed are through the production of covalent bonds. So covalent bonds are formed when atoms share a pair of electrons to fill their outer shells. So valence electrons that are unpaired in each of the individual atoms are going to interact and be shared between two different atoms. This is going to create a strong bond because it produces stability, because those valence shells are filled up. So there are two types of covalent bonds, and the type of covalent bond that is going to form depends on how strong the attraction is between the atomic nucleus and the electrons that are surrounding that nucleus. So we call this electronegativity. So electronegativity is simply the ability of the atomic nucleus to keep an electron pulled towards itself. In other words, if it is interacting with another atom and sharing an electron to fill its valence shell, electronegativity is a measure of how strongly it's going to pull that electron towards itself. Now, keep in mind that a covalent bond is a shared pair of electrons. And so neither one of those atomic cores is going to pull that electron so strongly that the other one loses it. They're going to keep it in between in essentially what turns out to be a little atomic tug of war. So each of those atomic nuclei is going to attract the electron. Now, a higher electronegativity indicates that that atomic core of that particular atom is pulling more strongly towards itself. As far as our biological molecules are concerned, hydrogen and carbon both have relatively low electronegativities. That means for any shared electron, they're not going to pull that electron very strongly towards itself. However, oxygen, along with nitrogen, both have very high electronegativities, with oxygen being the highest. So what that means is that if something is bound with another atom that has a higher electronegativity, electrons are going to be pulled more strongly toward that electronegative atom. So if we've got a bond between anything and oxygen, oxygen is going to pull those electrons towards itself. So there are two ways that these electrons can be shared between electronegative atoms. Now, all atoms are going to have a little bit of electronegativity because all atoms have that positive core, so they're all going to pull some electrons towards that atomic core. But if we have two atoms that have similar pull, it's kind of like a stalemate tug of war. And we call this a non-polar covalent bond. In a non-polar covalent bond, two atoms with similar electronegativities are going to share their electrons equally. Now, what this is going to mean for the atom as a whole is that there's not going to be any charge difference between your atoms. And we'll see what this means when we look at polar molecules. But basically, if we have an electron that is being pulled towards one atom, it's going to spend more time there, which means that atom is going to take on a slight negative charge. So in a non-polar bond, we are going to have equal sharing, which means electrons are equally likely to be found around either atom. And what that's going to produce is a charge neutral bond and a charge neutral molecule. Now, this is not the same thing as losing or gaining an electron. What we're talking about here is where those electrons are spending their time. And if they're spending their time equally between two different atoms, we're going to have no difference in charge between those two regions. And the formation of nonpolar covalent bonds, or polar bonds that we'll see in just a few minutes, is going to affect how this molecule interacts or doesn't interact with water. So a nonpolar molecule does not play nicely with water. And that's because there is no shift in negativity because of electrons. They're being shared equally, which means their charge is distributed equally across that bond. So I like to think of a nonpolar covalent bond as like a really good relationship where everyone is giving equally, no one is taking more than they need, and everything is shared nicely. It's kind of just a weird little analogy that I came up with. Polar covalent bonds, on the other hand, are bonds that are formed between two atoms with different electronegativity. Now, we talked about how oxygen has a high electronegativity and hydrogen and carbon have a low electronegativity. So when you have oxygen within a molecule, it is very likely that your molecule is going to become a polar molecule. And what happens here is that because oxygen has that really high electronegativity, it's going to pull electrons more strongly towards that oxygen, which means that around an oxygen in a bond, you're going to get that electron spending just a little more time and not as much time around the hydrogen. Because electrons are negatively charged, we're going to get an increase in electrons around the oxygen, which means we're going to get a more negative charge around the oxygen. Now, keep in mind that these atoms are sharing their electron. So the electron is not being pulled all the way away from that hydrogen. It's still attracted to that hydrogen. It's still spending some time around that hydrogen, but it's spending more time around the oxygen, creating essentially a cloud of negativity around that oxygen. And so what that means is you are going to have a molecule that basically has sort of an artificial charge. The whole molecule itself is not charged, but you're going to get regions of higher and lower charge in your particular molecule. So a polar covalent bond is an unequal sharing of electrons, which means that one is going to pull a little bit more. So I like to think about this as like kind of a normal relationship with its ups and downs. Sometimes you fight because someone is taking a little more, the other one is giving a little more, and so on. So you have sort of an imbalance in what's happening in that relationship. So here is a diagram that shows the difference between the electronegativity in a nonpolar covalent and a polar covalent molecule. When you have two atoms that have essentially similar electronegativities, and you have the atomic nucleus in the center with those electrons surrounding it, those electrons are going to be found equally between one core and the other core. However, in a polar covalent molecule, you're going to have those electrons being pulled more strongly towards that electronegative atom. And what that does is create a region of charge. And we draw this on our diagram by this little symbol here. And what that really just shows is that we have a partial negative charge and a partial positive charge. So we haven't lost or gained any electrons totally from this molecule, but they have moved around and sort of redistributed the charge. So a polar molecule contains polar bonds, and a nonpolar molecule is going to contain nonpolar bonds. But these are both still covalent bonds with shared electrons. So down here on the bottom, we have some examples. This is water. This is carbon dioxide. These bubbles sort of show the atom themselves, and what we are looking at here is oxygen pulling those electrons more strongly towards itself. So this is going to be an example of a polar bond. And then we have in the center here a little bit of a tricky one. So what's happening here is that we actually have a nonpolar molecule because we have oxygen on either side. And so what's happening is we get an equal distribution between those two oxygens, because essentially across that carbon, those oxygens are holding electrons equally. And so we don't get the same charge distribution that we might see with a polar molecule where that oxygen is pulling electrons away. So each of these oxygens is pulling equally across that carbon, producing a nonpolar bond. So we don't have any partial charges here. In this polar molecule, we've got the partial positive here because electrons are being pulled away from the hydrogen, and a partial negative because those electrons are being pulled towards the oxygen.